So 7.7, complex fractions. It just sounds bad, doesn't it? Complex fractions. So it means fractions over fractions, is what it basically means. What do you do when you've got fractions over fractions?
You flip the second.
You can do that. That's actually one of the techniques, is to flip the bottom one. But it won't work in the ones in about, it worked fine actually in these first two. But when they get harder, when they have another fraction added on the bottom, like that, you actually can't flip them both. It's not true. So rather than give you two different ways, let me just give you one way that'll work for everything. So I'm not going to do the flip way because that'll only work part of the way. So basically, here's the game plan. So what do they even want me to do? They say simplify. What do they mean simplify? Well, just make it a little nicer. Make it not such a big, ugly fractions over fractions, you know. Make it just a regular fraction, not fractions over fractions. How can we clean it up? Basically, let's take aim at both the denominators. So that would be the 4 and the 12, yeah. Just take aim, and if I can just get rid of those, then it won't be a complex fraction anymore, right? If I could somehow get rid of that 4 and get rid of that 12, 1 over 5, that would just be a norm. Now, that's not the answer. It's a little more complex than that. But that's basically the idea, is get rid of the 4 and the 12, and then you'll just have a normal fraction. That's generally what they want you to do, is simplify it by getting rid of the extra denominators. Okay, well, how do you get rid of that 4 and 12? I mean, legally, mathematically. How do we get rid of that 4 and that 12? What if you had a couple of fractions, 1 over 4 plus whatever, x equals 1 over 12? How would you get rid of that 4 and that 12? Say it was like that. You've done those.
You multiply.
LCD, huh? Yeah, you would multiply through by the LCD. That's exactly what we're going to do here. It's just top-bottom instead of left-right, but basically the same idea. And what would be the LCD, common denominator, if you had 4 and 12, you know, sideways or vertical, whatever, same thing? What is the common denominator for 4 and 12?
12.
It's 12, huh? Because 4 already goes into 12. 12 already has the 4 in it, so to speak, right? 4 already goes into 12. So yeah, you don't need to multiply 4 times 12 and get 48. That wouldn't be the lowest common number. The lowest number they both go into is 12 itself, isn't it? All right, so now what am I going to do? Here, let me go back one more time, having just erased that. What would I do in this kind of situation? I would multiply through, no, don't write this down. I mean, this is not what we're doing. But I want to try to link it to what you already know to show you that we're not doing something amazingly different. It's the same thing we did before. It's just vertical instead of sideways. Wouldn't you just do this and then you would cancel, you know, you remember those, right? 4 into 12, cancel there, etc. Right? That's what you would do. You would multiply all the 12s sideways. Well, that's exactly what we do here. We just multiply the 12 on the top and the bottom instead of sideways. That's the same action. And really, if it helps you, it's really 12 over 1. I mean, you don't have to write that, but that's what it is. It's really a 12 over 1. We're doing the same thing to the top of the fraction as we are to the bottom. So that's what makes it legal, so to speak, you know, makes it okay to do, because we're not really changing the fraction, right? When you do the same thing to the top and to the bottom, you're not really changing the fraction. Okay, and now we have to cross cancel, right? So I'm going to go 4 into 12 3 times, and here just 12 just cancels 12, there's gone. So what are we left with on the top then? Just 3. Can you all see how the top is just 3? 4 goes into 12 3 times. And then on the bottom, what are we left with? Just 5. And we're done. That's it. 3/5. What did we do? We just made it a simpler fraction by multiplying top and bottom by the common denominator. So that's kind of the same thing. It's what we pretty much always do with fractions, is identify the denominators and multiply either top, bottom, or left, right, you know, depending on what we have, by the common denominator. I'll try the same thing on number 2. So first, you know, take aim at the denominators. Can you tell what those denominators are? See the 9 and the 7, right? Are the denominators there? So yeah, so in that case, you're just going to multiply those guys together, huh? So multiply those together. 63 would be the common. All right, so, okay, so let's multiply by 63 and by 63. Is that good? Because that's the 7 and 9 common denominator. I just multiplied 7 times 9 there. Got 63. Right, that's the common denominator for those two. We good there? So 63. And then we cross cancel, right? Because that's really a 63 over 1. 63 over 1. Now, you don't have to write that, but if that helps you, there you go. Okay, and we're going to cross cancel. So I'm going to go 9 into 63 7 times. So I'll have 8 plus x times 7. And on the bottom, 7 into 63 9 times. And I'll have 8 plus x 9. And we can just cancel these out, huh?
Cancel those.
7 9.
We've got 7 9. Hey, come on, Maurice.
Are we good?
I want you to take 73.
So you wouldn't
Yeah.
You could distribute. Yeah, good question.
it would give you the same.
But in the end, it'd be, yeah, if you distributed the 7, like boom, boom, you'd get 56 plus 7x. On the bottom, you'd get, 72 plus 9x. But then you'd have to factor. And you'd go right back to the same thing. You'd take out the 7, take out the 9, see, you'd go right back, same thing. So just save a little work to just cancel them instead of distributing. Are we good there? Does that make sense? All right. Okay, there you go. So take aim at what? At the denominators, right? We want to take out the denominators. So we're going to take out the denominators. Yeah, because 7, yeah, you're taking aim at the 14, 7. Yeah, what does 7 and 14 both go into? 14. Yeah, 14. You don't have to multiply them together this time. So everybody see how I'm doing common denominator? So you just grab the two numbers, ask yourself, what do they both go into? Sometimes you need to multiply them, sometimes you don't. Just sort of depends. So 7 and 14, they both go into 14, right? Whereas the last one, I had 7 and 9, they both go into 63. You have to multiply them, right? All right, yeah, so 14 is going to be the common denominator. Now, what am I going to do with that 14? I'm going to multiply every term, and there's 2 of them on the top, 2 of them on the bottom. Does that make sense what I'm doing there? Because you have to do equal treatment. We can't play favorites, right? We have to do all the terms on the top, all the terms on the bottom by the same thing. That's what keeps it legal, so to speak. That's what means we're not really changing the fraction. Multiply top bottom by 14. That good. And then cancel. Remember why we were doing this? We were trying to cancel the denominators.
I get 42 plus 5 on top.
Good. Right, that's really a 14 over 1. They're all 14, so 14 over 1. So they cancel here. And 3 times, these guys multiply, don't they? 3 times 14, because there's no canceling. What's that, 42? Plus 5. On the bottom, 14 times 1 multiplies. And then here, 14 over 1. These cancel. 7 goes into 14. 2 times. That's going to be 3 times 2, or just make it 6. Is that good so far? And what's that, 47 over 20? We're done. You don't have to, you can't, nothing divides into 47 and 20. It's fine to leave the top bigger. So we just leave it. We're done. What did we do? We took something that was a big, messy fractions over fractions and just made it a normal fraction. We simplified it, made it smaller, simpler on that. Is that good? Is this making sense? Take aim at those denominators. All right, want to try number 4? Same thing. Multiply top and bottom. Hey, what could you do with these 2 negatives right away? cancel them, right? Negative over, it's a big fraction. 2 negatives, positive. Gone, right? 2 negatives make positive when they're in a fraction, don't they? When they're divided, 2 negatives divided. Just ignore them. 2 negatives make positive. Give you a second. Compare. Okay, so let me help with this. One thing is you want to keep in mind what we're trying to do here. There's 2 things we do with denominators. Sometimes we try to make them the same, and sometimes we try to wipe them out. What are we doing here? We're trying to wipe them out. That's usually what we do with denominators, is we try to get rid of them. Are you tracking with me? So in other words, you don't want to, here's a mistake that's easy to make that I've seen a lot over the years. People will go, oh, I know how to handle this, Ms. Heron. You just got to multiply top and bottom of that one by 5. That'll make his denominator 10, and then they'll have the common denominator. There is a different time when we do that. I mean, if you were like adding couple fractions, that would be exactly right. In that case, I would want to make common denominators. But that's not what I'm doing right now. I'm killing them. I'm getting rid of them. I'm taking them out. I want to say whatever I can to help you. I know, so I try to say, the goal in your mind. As you're working, think, I'm taking them out. It's a hit, man. That's usually what we do with common numbers. So I'm going 10 over 1, 10 over 1. Right? I'm not trying to make them the same. I'm trying to kill them. Trying to get them out of there. Right? So 10 over 1, 10 over 1. Okay. Now let's take it out. 10 into 10. See, it just died. It's gone. So that's 3 on the top. 2 goes into 10 5 times. The bottom is 15 times 5, whatever that is. 75. And now that fraction is actually reducible, isn't it? You can, what goes into the top and the bottom there? And divide them both by 3, it'll be 1 over 25. So that means that big old mess is the same as 1 over 25. We just cleaned it up, simplified it. Is that making sense? So maybe it'd help if I'm always saying, yeah, we're multiplying by 14 over 1, 14 over 1, 14 over 1, 14 over 1. In this case, 10 over 1, 10 over 1. It's always over 1 that we're multiplying by for the purpose of eliminating the denominators. Good. Questions on that one? Yeah.
So what happened with those negative?
2 negatives made positive, right? Whenever you divide, right? You know that, right? Yep. Negative 2 over negative 6, that'd just be positive, right? 1/3. Right? 2 negatives make positive when they're in a fraction.
So if only one of them had a negative side in front of it, it would have been a negative.
Correct. Yeah, right. So if top or bottom wouldn't matter at all. Really good question. Right? Everybody good with that with a fraction? If you just have 1 negative on the top or 1 negative on the bottom, it's all the same. It's just negative. But if you have 2 negatives, it is positive. Exactly right. Good question. Other questions? That's what happened. The 2 negatives right here just canceled to become positive. It's not negative anymore. Other questions on that one that I can answer?
I have a question.
Yeah.
On the bottom, when you do you reduce the 2 and the 10 to the 5, you can't do the 5 into the 15?
Oh, good question. So yeah, why don't we go 5 and 15? Because they're both on the top. They multiply, not cancel. We only cross cancel, bottom to top. Really good question. Right? She's saying, why can't I go 5 and 15? Yeah, so the 5's the top guy. So things on the same level are going to multiply times. Things bottom to top divide. So that's why 2 divides into 10, because 2's bottom, 10's top. So we divide top to bottom, multiply when they're on the same. So if 2 things are both in the top together, or if 2 things are even both in the bottom together, they will multiply instead of divide. Good question. Everybody good with that? Dividing is top to bottom. That's why 2 goes into 10, bottom to top. Cross cancel, right? Diagonal on that. Good. All right. Try that one. So you're taking aim like a hitman. You're taking aim at the denominators, right? You want to take them out. So take aim. Put your sights right there and right there. It's a very violent topic, I guess. Or I'm making it so. So what's the common denominator? Just A. Yeah, you don't need 2 of them. Just A. And what are you going to do? A over 1, A over 1, A over 1, A over 1. Everybody gets 1, right? You with me? A over 1, A over 1, A over 1, A over 1. Good? You're doing it to take out the denominator. All right. So A cancels A. B plus, and then here, 1 cancels 1, it's just A. Good. And here, A cancels A, it's B over 1, or just B, minus, and that's just A. Are we good to there? Questions to there. Questions I can answer. Is there anything I can answer? Everybody see what happened? I just simply put A over 1, A over 1, A over 1, A over 1. And I just cancel. Cancel. Everybody see that? These just drop out, so all we have is B. Right, that led to that B right here. And these cancel, that led to that A right there. These cancel, that led to that B. And these cancel here, and that led to that A. Is that making sense? Can I go further?
No, you can't.
Yeah, good. You remember the Costco thing, right? I can't cancel those B's, can I? Or the A's. You can't do it. Because remember, things that are plussed and minused, are like a Costco package. That's what I was talking about last time? I don't remember what. I talked about it today in 2 of my classes at City College. Pre-calculus and intermediate algebra, same as this, we call it by a different number there. Yeah, I mean, it's all through the curriculum. You want to know that. Things that are plussed and minused are glued together. That makes them a package deal. So which means that you can't cancel them unless you cancel the whole thing. Like shopping at Costco, you got to buy the whole package. That's why I say it's like Costco. Plus and minuses, glue them together. So that means if you want to cancel anything on the B, you go like that and cancel the whole thing or nothing. He's a package deal. B plus A, glued together, right? You buy the whole package or you buy nothing. You can't say, I just want the B, thank you. You can't do it. So we're done. They're not exactly the same, so we can't cancel the whole package, so we don't take anything.
Okay.
That good? Questions I can answer? How we doing? Try another one? Okay. So take aim. Take aim at the denominators. So put them in your sights. There they are. There they are. All right, we good? So we take aim at the denominators and then we just take them out by multiplying y minus 4 over 1, y minus 4 over 1, y minus 4 over 1, and y minus 4 over 1. Is that good so far? Multiply all of them by that. Okay, so why the y minus 4? Because that's the 2 denominators. See how I just take aim at the denominator, then I multiply that over 1 to all of them. Okay, so now what do we do? Remember that the name of the game is you cancel anything that matches bottom top. So like this and this, and this and this. But all the other stuff will multiply, won't it? The only things that cancel is when they match top and bottom. The other stuff multiplies, meaning what? It's going to be 8 y minus 4. These guys are going to, because that's 8 over 1. They're both top. See how that 8 and the y minus 4 are both top? So they will actually multiply, which I'll carry out in a minute, plus 8, right? This 8 here. That makes sense. On the bottom, these guys will multiply. Y times y minus 4 plus 3. That 3 right here. Does that make sense so far?
So far, yes.
So everybody see that? So when it matches top and bottom, it cancels, right? But when it's just side by side, it multiplies. Everybody see that difference? Okay, now, can I cancel these y minus 4s?
Yes.
No. This is what? And this is what? Glue. That's Costco glue. Remember, pluses and minuses glue things together, which means this, because I know you might look, yeah, but but the 8 is just multiplied. Yeah, he's not glued, but this whole thing is glued to that whole thing, isn't it?
Oh, you just ruined our world right now.
Remember, plus, I mean it. They mean it. Math means it. Anywhere you see pluses and minuses, they are glue. So that 8y minus 4 is glued to the 8. Which means what? If you want to take anything up there, you take it all or you take nothing. You don't take part. It's a glued package deal like Costco, all or nothing. So you think, well,
Distribute now?
yeah, so instead, let me rewrite it here. So instead of doing that and this, we can't cancel, right? So what do we do instead? Just distribute, gather like terms. So what do we have? 8y minus 32 plus 8. On the bottom, the y distributes. Y squared minus 4y plus 3. See what happens there? See how I distributed? Because I cannot cancel because of the glue. Now we gather like terms. So now, minus 32 plus 8. What is it? Minus 16? 24? 24. 28, yeah, is it minus 24? The bottom, we'll just leave it for now. Yeah, now, this one keeps going. What, is everybody good to hear?
So do we factor?
We factor.
Yeah, now we have to factor top and bottom.
3, no?
Yeah, that one, this one just keeps going forever. We're going to factor now. How do you factor this top? What can you factor on the top now?
Yes, I all
Take out the 8. It's a GCF, right?
minus 3.
Leaves y minus 3. How about in the bottom? How do you factor? Remember, you're looking for two numbers that multiply to be 3, add to be minus 4.
Parentheses, no?
So you get the
Y and Y.
Y and y. What are two numbers that multiply to be 3? 1 and 3. If they're both minus,
And
they'll make minus 4 in the middle, and two negatives will multiply to be positive. So that's right, huh? Minus 1, minus 3.
and
So
then we
now
can
you-
cancel.
now you can cancel.
Yeah, can we?
Yep.
Can we cancel
Yeah.
these y minus 3s?
Yes.
Yeah.
Yes, there's no extra, they're not glued to something else, huh? So we can do that. Yeah, now this cancels that. So there's the final answer, 8 over y minus 1.
We're almost there.
Yeah.
Question back up to the top,
Uh-huh.
where we could cancel them before. What would be a scenario where we could? They would have to look the same, or they would have to be able to divide into each other?
If these right here were times. If those were times, we'd totally cancel those y minus 4s. Does that make sense? So it's only pluses and minuses that are glue. Times is not. Does that make sense? Those were just a huge
Minus 4,
difference.
you put
Plus and
minus
minus
1.
versus times.
You need to put minus 4.
No, no,
But
you
you
can
can
just.
get rid of that, you can get rid of the times, okay? And we make the bottom.
And then remember to cancel that one.
Oh, it's 1 and 2. Oh, thank you. And this is the last one.
I like my life on this shit, and I got it. I'm kidding.
I get a flashback.
Right, but if they did, you can cancel them, right?
So are you saying, are you asking, like, what if you had x plus 3 over x plus 3, and they look totally the same?
An appropriate
It does
time where I
one.
can cancel though.
Right. So are you asking that? Like, what if they're exactly the same?
Yeah, those-
Even though
You
they
can
have plus?
cancel, you just
Yeah,
put one.
yeah, remember, catch what I'm saying. You can cancel. Go to Costco. You wouldn't go to Costco, right? Say, well, what can I buy here? They would say, you can buy any package you want. You just can't break the package. So my point in that, that's part of the facility. Everybody get that, you can cancel things with pluses,
The neighbor,
but you can't break the
neighbor
package.
carnicería.
And by the whole thing, yeah, so I
que
cancel the whole extra food, the whole
$1.
Oh, right.
So then we,
My
what if
packaging
that's
costs
an
more.
x squared
Yeah.
plus 6? What can you do there?
If that's an x squared
Because in my
Plus-
mind, I'm thinking I can divide.
over x plus 3,
Yeah,
nothing. Yeah, and I know you're thinking, well, doesn't x go into x squared, right? Or doesn't 3 go into 6? Can I just make that x and 2, kind of like? I mean, that's not a bad thought. It's wrong. But I want to, no, that's super good that you're asking this. This is exactly how I learned algebra too. I would go to my teachers all the time and go, why can't I? And they would show me, and I would grow my understanding. Yeah, the reason you cannot do that there is because you're treating them individually. Right? Aren't you grabbing this x alone and taking him in? And he says, don't ever grab me alone. I'm glued. So you can in no way think of him as separate when he's glued. So that's the correction in the thinking. Whenever you see plus or minus, package, you always take package. Whereas if that was times, if those were times, I would totally go, yeah, x into, it would totally be x times 2. That'd be great. Yeah, good. Good, all right. So there's big bad number 8. Let me help with number 8. What are you supposed to look at first? Take aim at the denominators. Right there and right there. And what do you notice about that denominator? And what do you notice about that numerator? They need to be factored. Yeah, first, before you do anything else, factor this and this first. First, factor those guys. Like we learned, take out the GCF, and the other one is difference of squares, right? Remember how we learned to factor those? So first factor, then do the hitman, take them out. Stuff will actually be easy at that point.
X plus n.
And it's going to be x minus n.
All right, you know what I mean? Take an H here. Keep your n's from looking. It's bad. I don't know why they mix like h's and n's. I mean, that's just confusing. They look almost. I'll try to make sure mine look different. And then how do you factor x squared minus n squared?
X parentheses, x plus n.
Yeah, x plus n, x minus n. Are we good there? Okay, so are we good there with the factoring? Remember that's just straight out of the last chapter. Right? How we learned to factor. I just took out a GCF, took out the H they had in common, and then I factored difference of squares. We good to there? All right. Now take aim, right? Take aim at what? Always the denominators. Take aim right there, and take aim right there. At the denominators, and you're going to multiply top and bottom by the common denominator. What's the common denominator? Well, what's something they both go into?
X minus n.
Yeah, the whole thing, the bigger one, right? X plus n, x minus n over 1, x plus n, x minus n over 1. Question?
Yes, why couldn't you reduce the top one before?
Oh, you know what? I think that's a great idea. You know what? Let's do that. I forgot, and your idea is a great one. Let's go back and do that. Yeah, look right here. We can totally do that, huh? And that'd make it way easier. Let's totally do that. H over, thank you. H over x minus n over x plus n, x minus n. Yeah, now it's a lot easier, huh? Yeah, we can just cancel those right away. So I canceled, and I took the whole thing, so it's fine, right? Bought the whole package, that's fine. Now take aim. Now go back to taking aim again.
X minus n.
And it's just x minus n. It's much easier now, huh? Does everybody see that? Yeah, that was a good plan. Now just multiply top and bottom by x minus n over 1, x minus n over 1. It's always over 1, right? Because you're trying to take out denominators. Everybody see that? And then cancel, cancel.
And then we get h plus.
H over x plus n, and we're done. How are we doing? Is that okay? So it's really about factoring and, yeah, noticing that cancellation there. Okay, questions I can answer?